One more example on this sound level stuff. You're now at a rock concert and you love loud music, and you're sitting 5 meters away from the speaker. So this is 5 meters, and there you are. And of course you're so close, your hair may be blown straight back a little bit because the sound wave is hitting you. Love that feeling. But halfway through the concert, you need a little bit of a break. So let's change it over to about 80 decibels, so you're not blasting yourself so much. So here you have some kind of new R, and the intensity here, maybe your hair is not being blown back so far anymore. This is 80 decibel, and right here that's 100 decibel. What's different about this apartment is we're not given the original power. We're still going to have to assume that the area kind of spreads out as the square of the radius. It may not be perfectly spherical, but it should still spread out as you move further and further away. I could, of course, based on the first situation, work out, my given loudness 1 is 10 log base 10 intensity 1 over the original intensity, and then I get the intensity, and then using the intensity I can get the original power, and then I can use the same thing as always. But I just want to demonstrate a slightly different thing. When you compare 2 decibel levels, we can kind of work around a few constants a little bit just to make things a little cleaner. So we're going to look at, instead, we're going to subtract loudness 1 from loudness 2. So that's 10 log base 10 of I1 over I0 minus 10 log I2 over I0. And what happens when you subtract logs? You would, of course, divide. So we have I1 over I0, and then dividing is multiplying by the reciprocal, and then the I0 goes away. So that makes things a little cleaner for us. We of course know that L2 minus L1, that's 20 decibel because we went from 100 to 80. And then we still have 10 log I1 over I2. Rearranging, we get 2 is equal to log I1 over I2, 100, which is 10 square, I1 over I2. So we know that I1 is 100 times as intense as I2. Once again, that's a logarithmic scale, so the number gets big really, really quickly. Then we know power over area of the first one is equal to power of the area of the second one. Now the power is the same for both spots because it came from the same source. That can go away, so then I know A2 is equal to 100 A1. Then we invoke the fact that even though it may not be perfectly spherical, so we can still say it's directly proportional to R squared. So that's why it's a weaker assumption, which is a little better for us. From here we know that R2 squared is equal to 100 R1 squared, so R2 must be 10 times of R1. R1 being 5, so this must be 50 meters. So you have to move 45 meters back from your original 5 meter spot to get that level of decrease in the loudness of the sound.